Imagine you are on Mars and want a fresh, juicy tomato. Sounds impossible, doesn't it? But human survival there depends on it. Today we will build a fully functional Martian greenhouse step by step. Mars is a hostile place, extremely cold, dry, and irradiated. We cannot simply plant seeds in the Martian soil. The planet's surface is bombarded daily by lethal cosmic and ultraviolet radiation. Additionally, the atmospheric pressure is almost non-existent. Water boils instantly. The first step is choosing the right location for our innovative space greenhouse. We cannot build on the surface due to deadly radiation and micrometeorites. The ideal solution is to place the greenhouse in very deep lava tubes. These natural caves offer excellent protection against radiation and thermal fluctuations. If we build on the surface, we must cover the modules with thick ice. The greenhouse structure must be inflatable, lightweight, but incredibly resilient. We use advanced composite materials that withstand the air pressure from inside. Now that we have a secure base, we must solve the soil problem. Martian regolith is full of toxic perchlorates that kill any plant. We must wash the soil with water to eliminate these salts. Water is extracted using robots from the planet's ice caps. After cleaning, we add bacteria and fungi brought directly from Earth. These microorganisms transform sterile Martian dust into absolutely fertile and living soil. However, classic soil agriculture requires a lot of water and space. Therefore, we will primarily use completely modern hydroponic and aeroponic systems. Plants will grow with their roots suspended in air or water. This method saves 90% of the water needed for traditional agriculture. Nutrients are dissolved directly in water and delivered precisely to each root. The next major obstacle is light, absolutely essential for the photosynthesis process. Mars receives only half of the solar light that we have. Global dust storms can block the sun for months without stopping. Our solution consists of using extremely efficient LED lights. These emit only the red and blue spectrums, which plants adore. Thus, we optimize growth and massively reduce the base's energy consumption. But where do we get the energy needed to power these bulbs? Solar panels are useful, but we cannot rely only on them. We need compact nuclear reactors for a constant energy source. Now we must create the perfect atmosphere inside our Martian greenhouse. Plants love carbon dioxide, and Mars has a full atmosphere of it. We filter Martian air, pressurize it, and pump it directly into the greenhouse. Astronauts exhale carbon dioxide, which the plants will absorb. In return, our vegetables produce fresh oxygen for the human colonists' respiration. This forms a closed ecological loop, the basis of long-term survival. The temperature must be strictly controlled because Martian nights are incredibly freezing. We use the residual heat generated by the nuclear reactors to warm the modules. We cannot grow just anything on Mars. We must choose smart plants. We start with lettuce, radishes, and spinach, as they grow extremely fast. Later, we will add potatoes, tomatoes, and strawberries for absolutely nutritious diversity. Potatoes offer many calories per square meter, being absolutely essential there. But another major problem arises. How do we pollinate these essential plants? We cannot bring bees to Mars. The reduced gravity will completely disorient them. Astronauts will have to manually pollinate the flowers using very fine brushes. In the future, we will use small autonomous drones that will act like bees. Martian gravity is 1/3 of Earth's, influencing plant growth. Roots might grow differently, but our space experiments offer huge hopes. The water in the greenhouse is continuously recycled through a complex filtration system. Condensation on the walls and plant transpiration are collected and purified. Not even a single drop of water is wasted here. Beyond food, the greenhouse offers a huge psychological benefit for astronauts. Seeing green plants always keeps people's morale high. The smell of wet earth and fresh leaves reminds us of our home. Tending the garden becomes excellent therapy against isolation and space stress. Waste management is absolutely crucial in this completely thermally isolated system. Inedible plant parts are quickly introduced into highly advanced special biodigesters. These transform them into organic fertilizer to feed the next generation. Properly treated human waste contributes enormously to fertilizing the soil of planet Mars. Advanced robotics will play a huge role in the daily operation of the greenhouse. Sensors constantly monitor humidity, acidity, and nutrient levels in the water. Robotic arms sow, prune, and harvest all vegetables with surgical precision. Artificial intelligence adjusts adjusts the light to maximize the yield of every green harvest. A dust storm hits the base, blocking access to natural solar light. The greenhouse battery automatically takes control, keeping LED lights and pumps on. The plants do not even notice the chaos unleashing outside right now. It is time for the first historic harvest, obtained directly on another planet. Astronauts pick large and crispy tomatoes, a huge victory for humanity. A simple salad becomes a true feast after months of canned food. Every bite proves that human life can thrive far from Earth. The next stage will be expanding these greenhouses into massive biodome-type structures. We will even be able to grow fruit trees or cereals for bread. Imagine the first fields of wheat growing under giant domes on Mars. With every plant grown, the terraforming of the red planet becomes much more real. Perhaps in the future, Mars will have its own vast green forests. Learning to grow food there helps us protect Earth. The developed technologies will teach us to be sustainable on our planet. Space agriculture is the key to our future. As a completely stable interplanetary species, we are not just creating a simple greenhouse, but the seeds of a new civilization. If you appreciate our Martian journey, please subscribe now.